like rereading less. I just can't. I went in and I talked to the technologist, and I was like, whatever these are, they don't work. It's not what I said. Not Mike. Yeah, I think it's started.
All right, folks, we're going to get started here since we're at time. So this is TLS. If you thought you were somewhere else, it's time to find out where you're supposed to be, or you can stay and have a bunch of fun here. Haha, yeah. All right, and part of that fun is understanding the note well. So hopefully you have all read the appropriate documents about IPR, behavior, code of conduct, all that good things to know. If you haven't, it's really is a good thing to be familiar with. And if you've been participating in this working group for a while, you realize these sorts of things do come up in discussion. Also note really well, on the conduct within the working group, we expect people to treat each other professionally and respectfully. And if you believe that, there's problems, there's ombudspersons and other means for reporting this type of issue. Meeting tips. So please, if you're in the room, do the on-site tool so that we can record your attendance and so that you can join the mic queue and participate in the discussions that we have. And then online, please mute and turn off your camera until you are speaking. Thank you. All right, today we have an agenda here. Let's see, on Thursday, okay, we'll have a talk about trust anchors. We'll have a section on PAIC. We have a couple presentations on ECH and then some discussion of attested TLS. Any bashing of the agenda or items to consider? Jonathan?
Wow, who's really tall? Hi, Jonathan Hoyland, Cloudflare. We talked about Rec MTLS last session, and there are now different people in the room. And so I'm hoping we're going to get some different support at the mic for adopting Rec MTLS.
Okay.
So from Google, we are looking at MTLS, request MTLS, as a way to identify our crawlers, and we are happy to try it out.
All right, thanks for letting us know.
So yeah, if we can do an adoption call on the list at some point.
All right, so I think we'll jump into our agenda with David. Do we have him? In theory, it should work.
I assume it's this button, or is it
Yeah.
this? Okay. All right. Well, I guess now we'll see if the button. Oh, I'm also not that tall for this. Hi. Hello again. It's this stuff. Hopefully this will be a fairly low-key presentation because we only just got adopted, and also I've been suffering from jet lag, so I haven't prepared quite as much as I would have liked for you. But, oh, it worked. Excellent. Okay, so the status is we have published draft 00. Yay. It's the same as what was talked about in the adoption call because people get antsy when you change the draft between adoption call and the draft 0. What is our plan? So I've been going over the various bits of feedback. We've gotten over the list and whatnot. Obviously, since it was before adoption, we couldn't really get clear signals of what we could figure out what the working group's consensus was, but it was good to find what points were interesting and or confusing and whatnot. So we found various bugs in the tracker and are going to slowly make some editorial changes to clarify the initial design. Obviously, this initial design is just draft 0. I'm sure that it will completely change by the end, but I figure it's good to make sure that what we're starting with, it's very clear we're all on the same page as to what we're starting with. And then beyond that, a lot of the feedback sort of points to interesting decisions that we made in draft 0 based on such and such trade-offs. And now it's time to sort of go to the broader group and look at the trade-offs that go into those decisions and see if we should change them slightly. The goal right now for this presentation is just to collect the decision points because of jet lag and also because it's pretty early. I'm thinking we'll just get folks thinking about it, and then we'll have some more detailed discussion on the list. So editorial stuff. There's been various things that we noticed were kind of confusing. Trust anchor identifiers is the most annoying phrase to say ever. So let's just say IDs, and we'll just like say ID stands for identifiers once, and hopefully the RFC editor will be happy with that. Some things were like not very clearly written. The retry flow in ECH is an interesting thing to define. So we'll try to go and clear that up. If there's anything that's confusing that we missed, please go file issues or send email or whatever else, and we'll try to make that clearer. On to more interesting stuff. All right, so there's a bit in this draft that's about provisioning metadata about certificates. It seems that most ideas in this design space, in order to deal with the size of the trust stores, involve some flavor of the client sending a thing, the server having some information either in the certificate or alongside it that it needs to go match up in order to go and like decide whether or not the client supported that trust anchor. So what we ended up doing in the initial design was we designed this certificate property list structure, which is just like a key value pair that the idea is it's constructed by the CA, passed through your certificate issuance flows, certificate provisioning pipeline, like, extend the MIME type, add a new field to your proto or whatever you're doing until it gets to your TLS library, which can then go and evaluate it. And so that we only have to do this plumbing once, we figured, well, we should probably make it extensible to support other properties. If you imagine we had this 10 years ago or longer than that, maybe we wouldn't have needed this weird pre-certificates thing for certificate transparency. Instead, the SCTs could just have been delivered in there. This is prime bike shed territory. There's various traits. So this is somewhat inspired by a thread that some feedback Watson had on the list. That there's various trade-offs here between having the information in band and out of band. If it's in band, you sort of have to reissue the cert, and also it gets sent to the client. But you don't need to extend your plumbing thing, your certificate provisioning pipeline. If it's out of band, it's the opposite. So do we define one of these? Do we define both of these? Something else? We did a sort of TLS style thing with a registry of 16-bit code points. I don't really care what this is. At some point, we realized as and when attributes are a thing. I don't know if someone can, have fun picking which one it is. Let's see. Then there's sort of the big one. There's a DNS dependency in this draft. Oh, I can look over here. How convenient. There's a DNS dependency in this draft because trust stores are kind of big, or rather, some trust stores are kind of big. Some of them are also small, like if you're doing some sort of like single vendor PKI or like a client certificate PKI or whatever. Those are very easy. The working group already standardized a thing that can handle it. We're trying to bring this sort of convenience to the public PKIs as well. And so the initial design was to flip it from client offer server select to server offer client select, where the server lists available certificates by trust anchor in the HTTPS service B record, and then the client can go select from there. The nice thing is this aligns with other work that IETF is doing, the key share prediction stuff, things outside this working group like Quick and whatnot. We've got a draft to try to make it easier for servers to deploy this. But the downside is the servers do need to go and deploy something to go synchronize some stuff in DNS, and that is doesn't quite exist yet. Is this the design we want? There's a lot of there's a lot of like levers we can pull to adjust the importance of this DNS dependency, whether there is one at all. Boss has a very interesting client hello encoding. Kind of the trade-off here is the more stuff we can fit in the client hello within like a various size limit, then the less you need the sort of out-of-band information to help tailor what the client sends. We also have a retry flow, which can help also like the server can make slightly more educated guesses, safe in the knowledge that if it guesses wrong, it can retry. It's not the best flow, but like that gives us a little more room for things. So this is a large space of stuff that I'm excited to explore with y'all. Why is that not working? There we go. Speaking of the retry flow, the sort of dual of the DNS half of the current design is a retry thing, where when the server sends you a certificate, it also says, by the way, I have these other ones available. And so if the server says, oh, I didn't like that one, the client can, sorry, if the client says it didn't like that one, the client can try again and make another connection, or try again. And in the current design, we sort of patterned after ECH, also in this working group, and made it retry of another connection. We also got some feedback from a client vendor, not the one I work on, that this is useful for handling sort of more complex client policies where they're like, I support this trust anchor, but I sort of add these little tweaks to it. I don't want to speak on their behalf, but this is pretty, like, I don't know, it wasn't designed to handle that, and it sort of handled it on accident. So it would be nice to sort of preserve that property if that vendor is very excited about that. So I said we did this ECH style. Another direction we could go is to make the retry in the handshake, something like an HR-like flow or maybe something else. This will be more efficient, but it's more complex. I don't know, the working group we'll sort of have to work through this with the group and figure out, like, do we want to add, spend this complexity budget on something on this thing here? In designing that, it also impacts which side initiates the retry, which kind of interacts with other stuff. And I see Ecker is in the queue.
Hi, David. So just to make sure I understand I'm on video. Hi. I just want to make sure I understand design space here. Hang on. For the record, this is Chrome, so you know it's your fault that it's echoing.
I only work on the encryption bits. If it's anything else, it's not my fault.
It's true that this is encrypted. So just so I understand the design space here, the need for a retry flow is downstream of the DNS advertisement, right? If we like magically got rid of the DNS advertisement, we need the retry flow, right?
Mostly. So the feedback from the other client was that, and I guess I can't really speak to their use case very well, but I can describe a sort of similar one that shows up in other browsers where in the browser that I'm more familiar with, where you'll sort of support, you'll support a trust anchor, but then we'll be like, oh, this one's kind of on its way out, and then we want to and so like maybe we only support it for certificates issued before this time, if it's like partially distrusted. And you can imagine that if you're a server operator, you might still want to hold on to certificates from that trust anchor because you want to serve this other older client that has to go deal with it. But then you also want to issue a newer one for the client, for the newer client. And this gives a little this gives kind of like a get out of jail free card for things that are too complicated to express in the client hello. That is not necessarily the only way to slice this up, but so I think the answer is yes, with a little asterisk that depending on how we slice it, we might impact.
Right. That. Hang on. I guess the part I'm not quite understanding here is how does the server know who knows to retry? Because the client offered something, and the client said, in the version, in the sort of go back to certificate authorities version, right? The client just lists everything it's got, right? And the server gives you something actually you don't like. How do you know the server had something that you might have liked?
So, you mean in the current design, or?
Oh, well, the current design. In the current design, as I understand it, the client gives the server some unacceptable conditions, since the client server retries, right?
In the current design, the server says here. The server looks at what you've got, what you send, and says, "I'm going to send this certificate," and then also sends by the way, I've also got these other ones available. And the assumption is that that list is much smaller than the trust anchor, than the trust source, so we can just send that, and then the client can go. Oh, sorry, I didn't realize. Both looking at Ecker and also talking to them is challenging. All right.
The screen's in the back.
Yeah.
Very sensible ideas. All
Put
right.
the screens in the back, though. That would make more sense.
Sorry?
We should put the screens in the back. That would make more sense.
That would make a lot of sense.
Right
So kind
above
of
the mic, right?
awkwardly in this angle. Anyhow, what was I saying? Okay, so in the technology, in the current design, so the server sends certificate, and then I think we stuck it in encrypted extensions. You say, here's the list of IDs I also have. and then the client can like tear down the connection and be like, I'm going to go try again and say, I want this one instead. This is a very heavyweight retry that like is only like, you know, if things go wrong. I think in the case of like sort of the weird policies, the assumption would be that like almost all the time the server would like we would pick the right one, but maybe in some weird edge cases. So like I said, I think this is like, I think you are right that like it is mostly a DNS mismatch thing. It's just that like depending on how we like tweak the levers, like maybe it'll be different.
Fair enough. Thanks. I'm just trying to figure out what the knobs you have to turn on.
Yeah, and there's a reason I put these two after the format bike shed, because one, they're central, but they're also kind of big and daunting. So I figure we can get one of the like less high stakes bike sheds out of the way, and then we can move on to the next one. I mean, I'm just giving a menu right now, but you know, when mailing list discussions happen. All right. I see. 13 minutes. Okay, and then finally, other prime bike shed material. This design works by adding like small IDs to certificates. We currently allocated them based on OIDs because they're reasonably short once you make them relative to the PEN prefix. And they're very easy for everyone to allocate. That seemed like nice properties. But you know, any other ID scheme would also work. I propose we table this one and decide this last because all the other decision points might impact this one. For example, if we go with Boss's interesting client hello encoding, then there probably wants to be integers. Or maybe something else will happen. And that way we can defer one of the bike sheds. And finally, since you know, one of the things we noticed in the conversations was that there was a lot of like, oh, well, this might be slow, this might be difficult to do, and you know, unknowns about what will happen. We've sort of started some early prototypes just to get some implementation experience. Boring SL is a prototype draft 0 implementation. Hopefully we can run an experiment with any clients and servers that are interested and see how it goes. Obviously, this is all provisional. We're just doing this to get a sense of how it's going to work and things like that. Then we've stuck a little page in the GitHub with some provisional ID assignments. I will note that the previous slide I just mentioned, maybe we'll change the IDs. This is all, you know, provisional on like this will all, I'm sure all these IDs will get like removed and replaced with new ones because we'll probably make the IDs into like, I don't know, sonnets or something. It's fine. Yeah, but hopefully we'll have something interesting for y'all at some point. And with that, yeah, next steps is go work through those. Any other topics that you know we missed that folks think is worth discussing? There's a bug tracker like most documents, and or you can mail the list. And yeah, hopefully we'll get somewhere interesting.
All right, any other questions, comments? Okay. Then I guess we can move on to some discussion of PAKES. Laura, I think you're up.
Awesome. Hello, my name is Laura Bauman. Today I'll be presenting a draft I've been working on with David Benjamin, Samir Menon, and Chris Wood on TLS 1.3 PAKE authentication extension. This is based on a draft Richard Barnes started a few years ago that expired. So also shout out to Richard. Yeah. So currently, when peers only share a low entropy secret, there is no mechanism to directly establish a TLS 1.3 connection. Some use cases where this could be useful include connections authenticated with a user entered secret, such as a PIN or passcode, in cases like embedded or IoT device setup and pairing. I'd like to clarify, we're not aiming for general web login use cases. This is more for one-time connections or for an initial connection over which long-term credentials can be exchanged. So this is sort of just a motivating photo of like a pin on a device where you're connecting for WebEx. But this is sort of the flow I'm trying to envision for these low entropy secrets, not really passwords in the web login case. So TLS 1.3 does provide a mechanism for authenticating with a pre-shared secret with PSKs, but these keys must be high entropy. So again, there's no direct path to get from this low entropy secret to a TLS 1.3 connection. So if you're in a situation where you only have this like low entropy secret, every use case is sort of on their own to figure out a way to make that work if they want to use TLS. So some of them will devise a way to bootstrap up to a PSK or RPK, or they could end up using a less secure protocol or just remaining on TLS 1.2 with SRP. So our proposal is a TLS extension PAKE that can carry data necessary to execute a PAKE within the handshake. So again, we're sort of assuming that the PAKE registration phase will happen before the TLS handshake. So the client and server will both be provisioned with the shared low entropy secret, or in the case of an anonymous PAKE, the server could have the password verifier corresponding to the password. The choice of any PAKE and required parameters will be explicitly specified by an IANA assigned value. So each PAKE will be used as a black box, and the extension is meant to be pretty minimal in that you're not having to tune a bunch of PAKE parameters when you're using it. It'll be well defined in how that PAKE should be used. As a first use case, we've defined a concrete protocol for executing SPAKE2+ using the extension. So this is a general flow of how the extension works. Again, starting with step 0, out of band, there's a registration phase where that secret is exchanged and shared between the client and server. When the client goes to actually start the TLS connection, it sends an array of PAKE shares. So each PAKE share includes a PAKE scheme, which is an identifier for the actual PAKE algorithm you're using and any associated parameters. So this is the IANA assigned value, and then the first message of that PAKE. It also includes the client identity and server identity. The server selects the PAKE scheme that it recognizes and sends back the next message in the PAKE. And then at that point, both sides should be able to use the PAKE to derive a shared secret, and that is used as input to the key schedule in place of the ECDHE input. And then the TLS finished messages provide confirmation for the PAKE. Again, the actual content of the PAKE shares inside, the PAKE message inside the PAKE shares has to be defined. So we've defined what those need to be for SPAKE2+, but for other PAKEs, that'll need to be explicitly defined. So going to PAKE requirements, a compatible PAKE must provide forward secrecy since it's being used as input to the key schedule, and it must conform to this message flow we've described of basically one round trip and then the finished messages. So there are several current PAKE protocols that satisfy these requirements, including CPACE, SPAKE2+, and OPAKE. I've marked sort of 2 asterisks here, as these are sort of related to open questions brought up by Ecker on the mailing list. First one is whether we want to combine the PAKE shared secret with standard TLS key exchange so that we can get some post-quantum resistance. And if we're already using the standard TLS key exchange, maybe we don't need forward secrecy of the PAKE. So that could potentially be relaxed. And then in terms of PQ PAKEs, there isn't one currently. But if one does exist, there could be issues with the actual constraints we've put on the message flow so far. Jonathan?
Sorry, could you go? Sorry, Jonathan Hoyland, Cloudflare. Could we go back a slide, please?
Yeah.
So I think I misunderstood when I was reading this. Do you send the key share extension in the client hello and then just not use it?
So this is as the draft is currently specified, where we don't use the TLS key exchange at all. So again, it's sort of an open issue if we want to combine it. Or do you mean the PAKE share?
No, so in a client hello, is it a mandatory extension? Is key share? Do you send that extension or not?
As it is currently specified, no, but I think we're going to change that, if that makes sense.
Okay, so if you do send it, then are you just dropping the values on the floor?
Currently in the draft, we say it's either you can send it, but it's like if the server picks PAKEs, it wouldn't use the key shares. Yeah, you would drop them on the floor.
Okay, thank you.
Yeah. So again, I think this is something that'll change. I just wanted the slides to be consistent with the draft that we sent out. Yeah. So yeah, sort of getting into the open issues, I think the first one is certificates. There are use cases where it would be valuable to like additionally authenticate like one party besides just knowing the password. So again, Ecker brought it up on the mailing list. If the password is leaked somehow, and again, I'm using the term password loosely here, the attacker could impersonate either the server or the client, which could be really lopsided. So if there's also a certificate, then it would constrain it to only being able to impersonate the client or other such situations. So I've got a local branch where I'm starting to add that to the draft, but I'm pretty sure we're going to add support for certificates to be used with the PAKE extension as well. And then again, as I was just talking about, we want to combine with the TLS key exchange. So this will help provide some post-quantum resistance if you use like MLChem instead of having to, or a hybrid, instead of just using the PAKE for forward secrecy. And then there's sort of two questions more for the working group that are like a little less targeted around this approach is meant to be general, so it could be used with different PAKEs. If that is an approach we want to take, or if we want to have a more targeted solution of we're going to pick one PAKE and put that in TLS 1.3 or something. And then again, there's some modifications here that should probably have formal analysis and input from the FAT. So current status is we have 2 implementations completed with support. Oh, sorry, Martin, did you want to go? Okay. There are 2 implementations completed with support for SPAKE 2+, including an open source implementation and boring SSL. And I guess my questions for the working group are, do we view this as a worthwhile problem? And is our approach as laid out so far plausible, and are issues tractable?
Right. So this is good. I'm really happy to see people doing the work. We've had a lot of things. I don't have an immediate use for it. I work on a web browser and very much not interested in the web password thing. We have passkeys now. The question I sort of have is around the way in which you're treating the new shared secret material in the handshake. We have I think now several ways that you can get shared secrets into the handshake, but really it boils down to just 2. One is the PSKs that we use for 0RTT and a bunch of other things. And the rest of it, we've all decided to treat in more or less the same way. ECDH and the post-quantum chems, we just put them all in the same bucket and we treat them as a method. So I'd like to sort of ask whether or not you would consider making this just like another key share and running it through the handshake in that way. It means that you're potentially creating a combinatorial explosion in terms of the number of key share methods, because you would do this on its own potentially. I'm not particularly interested in that. I'm much more interested in this one plus ECDH and this one plus the ECDH and MLChem. You say quantum resistance. Don't say that. But I think those are the combinations that I think we should be concretely building, however we spell them. But I think this is approximately the right shape to take. I say that conditioned on the fact that you are able to get PAKEs like the ones that you had on the slides that work in one round trip. If there's anything that suggests that the more general solutions require multiple round trips, then I'm, scratch that and we can have another look at the architecture. But on that point, I would have you talk to folks like Deirdre, who's furiously looking for post-quantum PAKEs now, I imagine, and others who have investigated that stuff so that we can understand better what the future risk there looks like.
Howdy. Thanks for presenting this. Oh, yeah, I'm up there again. Yeah, thanks for presenting this. Could you go back to the previous slide? Right. No, one down. Yeah, there we go. I think this is my questions about this are entirely about like adoption interest. So if people want to do this, then like we should do this. I think we need a slightly higher bar of interest than we have in the past, just because of the sort of number of runs people have made this peak wall kind of failing. So like I want to see like a number of people who want to do this that makes it worthwhile doing. But if that's true, then like very crime relevant. I do want to make two narrow technical points. As I said in my email on the certificates, if we do make it work with certificates, we have to make sure that you don't get some sort of weird cross situation where you do like an initial binding to the certificate and then you resume with a PAKE and like somehow the origins get messed up. So it has to be done carefully. I'm sure it can. I suspect it can be done, but I'm not sure. But we have to be careful about it. And as far as the TLS key exchange, as I said, I do think we want post-quantum, and I think PQ PAKEs may be great, but like the natural thing to do at the moment is to like have the PAKE for authentication and the PQ for post-quantum, PQ DH for post-quantum, and call it a day, right? And I think I don't agree with Martin that it would be better to try to pretend this is yet another elliptic curve. I think it's probably better to think of it as a form PSK actually than an elliptic curve. Thank you.
Jonathan Hoyland, Cloudflare. So in the draft, you mentioned that if you're worried about the client ID being leaked, you should just do it inside ECH, which like, sure. But then you're in this weird situation where, let's say for some reason the server doesn't like your ECH inner, and it's like, I'm just going to fall back. That's going to fall back to using a certificate. Whereas if it doesn't fall back, it's going to use the PAKE thing. And that's going to look weird on the wire. I don't know. I don't know if it's a security thing. I just think it's ugly. I was thinking about what Martin said, and this seems like another place where we should use like importer keys. I had a draft like 400 million years ago, where it's like we should have a standardized way of injecting key material into the handshake. So yeah, I think it might make sense to try and do something more standardized and like have a standard way of injecting stuff rather than just shoving it in and hoping it's fine. And then on your last thing, the formal analysis, at least from a symbolic / Tamarin perspective, the draft as it's written, I think like doesn't need an analysis because we would just model the PAKE as a Diffie-Hellman thing anyway. And so it would be like our model wouldn't change at all to model this, as far as I know. Well, I mean, modulo like context strings. But yeah, so I don't think we'll need, well, maybe some computational people will say we do, but whatever.
I'm not a cryptographer, so.
Okay. Okay, Scott Fleur, Cisco Systems. I strongly support putting in a PAKE into TLS. On the other hand, the only PAKE that you specify in the draft is PAKE 2+. That has a very unusual property. It has a values, 2 elliptic curve points, M and N. If someone is able to find out the relationship between the two, then basically you lose the PAKE properties, and that brute force search from a single active exchange becomes possible. If you do put in PAKE 2+, I believe in the security considerations, you need to emphasize that.
Okay, thank you.
Hi, this is Hannes. There have been numerous attempts to define PAKEs in TLS, and all of them have failed. And the one that was published with TLS 1.2 SRP, which you mentioned, was unsuccessful in its deployment, which led to some hesitation to actually do further work on this, as we have seen in the group. So what did actually change since the last time that you think this is now going to be successful? You mentioned some of the use cases, but they, like IoT, many of the people who wanted to do the PAKE work, they have already incorporated their PAKEs into the IoT scenarios. Like we had this debate about Dragonfly and the CFRG work that was kicked off. So I think it would be useful to provide a little bit, I don't know if it's in the draft or maybe just on Mailgis or somewhere, to elaborate a little bit more on the details of the scenarios so that there is some at least some hope that this will go somewhere rather than, oh, wouldn't it be nice to have that feature because.
Yeah, I think from people I've talked to in the working group, there seems to be more interest this time among the authors and then a few others I've talked to as well. So I think the biggest change is I think there's enough interest in implementing it and adopting it. But I'll let others speak to that.
Hi, David Skenazy. Thanks for bringing this. I think this is great. So yes, I think we should work on this. To me, these issues, like I agree with some of the points made before, but they totally seem tractable. And so I think that makes a lot of sense moving forward. Hannes, you asked a very good question about what changed. I can't answer that. But if you look at the affiliations on the authors of the draft and you wonder if two devices could communicate locally from one to the other, you might be able to come up with something that could be built that's quite useful. Hope that helps.
This man is subtle. Tommy Polly Apple. Just kind of talking to the motivation, but I think this is good, and I think we should work out all the details in the group, etc. Absolutely, yeah, this is not something that if you're just doing a browser, this is going to be for you. I'm here speaking as someone who has written some sample code for iOS apps to like, here's how you do some peer-to-peer interaction based on this stuff. And my goodness, let me tell you, the original sample we had with the pin code, like it does not have good security properties. So this is a pattern, despite right, there are other cases where we may want to be doing this between more different platforms, etc. But even in these simple examples where we have patterns that we are telling iOS app developers to do between instances of each other, having a really easy to use, simple and secure solution that we can recommend that's going to be interoperable across platforms is really powerful. And I think that's the motivation. Not sure what IoT developers and stuff will do here, but even just like the mobile app space and the code that's being written into those apps is going to be really important.
Can I quickly respond to that? And so don't get me wrong, I always like the bakes and so on. But what I hear is like Apple likes their own work. And I hope it's more than Apple. That's all there is.
It is in fact more than Apple, Hannes. So this is Richard Barnes from Cisco. So I've been working with Laura and the Apple team on this. We have several use cases at Cisco of the same general device pairing onboarding flows cases. So yeah, we are, to the point Stephen making in the chat, like we are looking to ship this. Like this is not just another PIC that's going to go nowhere. So we've got multiple vendors. I believe I've heard some things about like Matter as a whole consortium of vendors doing some stuff with PICs as well. Yeah, so there may be some stuff coming out of there. So like there are real use cases across multiple vendors here.
And Hannes, very briefly, if you look at the author list, there's David Benjamin on there. And unless something drastic happened in the last few minutes, I think he doesn't work for Apple.
Thank you very much.
Thanks. All right, we have another PIC presentation.
Yes, thank you. Okay, hello everyone, morning. This is Xia from Huawei. I think this is another similar document as the previous one. It's also about talking about how to combine the PIC with the current TLS protocol. But this is proposed another option, which means that it's not the PIC in TLS, which is PIC after the TLS connection has finished set up. So, okay. So we call it the post-handshake PIC for TLS. Okay, here that's some we give some background or some reason why we need this kind of option. We think that this kind of post-handshake PEG for TLS has some good benefits. Firstly, it's very obvious that we don't need to change any TLS protocol because this PEG negotiation process is after the TLS connection has set up. And secondly, because everybody knows that the PEG can defend against the clear password leakage. Third point is that by combining this PEG authentication key exchange with TLS, we can provide some kind of like the defense in depth. We can make the overall security is better. And the last point is that with this post-handshake PEG authentication, and we can also achieve the channel binding with on the layer, TLS layer. So it can protect against the main media attack. So, okay, these are the some reason that we think this option is also useful. And note that there are already one draft talking about the post-handshake PEG for TLS before, but that draft is very specific for the OPEC algorithms. And we realize that this kind of solution is not very general and applicable for other PEG algorithms like the SPEG, SPEG2, SPEG2 Plus, and the CPACE, because the OPEC algorithm has a feature that the client and server have shared the long-term secret or the public key. But this feature, other PEG algorithms cannot, do not have. So we think that maybe we need a more general post-handshake PEG solution for TLS. Okay, next several pages is about some details about the current proposal. Firstly, we follow the TLS way. For the PEG negotiation, we need to define the some negotiation messages. So we have the PEG client hello, PEG server hello, and the PEG finished and PEG status, which is all these messages are responsible for a serious negotiation among the client and server to finish the algorithm negotiation and the key material sharing and the authentication and the integrated protect and finally the status notification between them. So all this message is used for these functions. And next two pages is we listed the two process. The first one is very basic, and the complete one, which is that the client has send its PEG client hello message with its supported PEG algorithm and its ID and its key share with server, and the server accept this algorithm and send back its server ID and the server share with the client. Then the both sides can with this key share to make its key calculation. Then the finished messages can perform the final authentication and the integrated check. So that's a basic process. And another process is that, of course, we also there are some corner cases that the server cannot accept the client proposed PEG algorithm. So it can send the retry request back to the client, and they renegotiate the agreed matched algorithms. Then going down following the same process as before, as the last page. So last page is about the channel binding, about the post-handshake PEG with the underlying TLS layer. So the basic idea is that we just use the existing TLS exporter mechanisms. With this kind of mechanism, we can get the exported secret and use it in the PEG negotiations. So with this way, we achieved the channel binding. So that's all. Thank you. If you have any comments, thank you.
All right, so I saw this was post-handshake stuff, and I got very confused, and I realized it wasn't what I thought it was. So there's a thing called post-handshake authentication in TLS 1.3, It's actually not this. It's like normal handshake messages that sort of go in, like they integrate into the TLS record layer. So that requires changes in TLS. And it was done because we sort of had this legacy thing with renegotiation that we had to support. This, from what I can tell, is not that. In fact, it doesn't seem to have anything to do with TLS at all, in that it is just some random protocol for speaking PAKE that goes over a stream-like channel that we happen to run over TLS 1.3, and then it has a little slot for sticking in a channel binding, which, you know, I haven't looked at it very carefully, but seems plausible enough. But I guess it's not like, I guess it's unclear to me what we would do in the TLS side, because we're not actually changing TLS here. We're just defining this protocol on the side. And so maybe we want to, like, if you're going to stick this in HTTP, maybe like HTTP makes more sense for this or something like this, or wherever you're planning on sticking this. Well, Utah is using TLS, and this is actually just a PAKE protocol that is independent of the TLS connection, other than like a spot for a channel binding. And, you know, there's been a lot of like various auth protocols that support channel binding. I will not fidget with this paper. Oh, it's not even exported. So it's not even that. So exported authenticators was a ship our org chart sort of deal, where we built post handshake auth that went in the connection, which was problematic in a lot of ways. And then we were like, actually we want to take it out because we want the flow to be different. And then we were like, oh, but we don't want to redo the formal verification. So we shipped our org chart and had the formal verification happen on one side and the bytes be transited on the other side. We don't have pre-existing formal verification to go back onto here. So this isn't even exporting anything, which I think is correct. I don't think we need to ship our org chart here. But anyway, I think this is like actually like less connected to TLS than it looks like.
Jonathan Hoyland, Cloudflare. Could you go to the last slide, please? Yeah, not that one. Definitely don't pick exporter - channel binding as your label. Other people are doing that. And that means if there are different things happening on this TLS connection, you'll derive the same key spaces. And anybody who's using exporter channel binding is wrong. I know it has an RFC number, but it's still wrong. Yeah, that's mostly what I want to say. The connection to EAs is, I think, a red herring. There is, Nick, didn't you have a opaque in? Oh, okay, yeah, there was a thing which tied PAKEs to EAs, but like, yeah, this is not actually tied to TLS. So like using the TLS shaping is just confusing, I think. But yeah, really don't use that string there.
Okay.
Yeah, I mean, my sense is, as David says, you've imported a huge amount of like sort of copy paste a bunch of TLS machinery into here and kind of invented a new authentication protocol that runs over TLS. I think what I would advise is, if you have important use cases that need something shaped like this, that you sort of swing back through like second dispatch with the use cases, and then we can talk about like where work like this would go if we wanted to invent a separate PAKE protocol, which could be like down to a channel underneath it. Because I think, like, you know, as David suggests, you know, you might run it over TLS directly, you might run it over or like HTTP. So it's kind of a generic thing that doesn't really have much to do with TLS other than needs a channel binding below. So I think, you know, I think it's clear what the use cases are for the thing we were looking at before, but I think the use cases here are a little less clear. So maybe I come back with that. Since I'm at the microphone, are the chairs planning to do any kind of roll-up of these two proposals for adoption calls, or are we just hearing the presentations and the chairs are going to figure out later?
What? So we will we'll do an interest call. So the call will be, are we still taking? Yeah, let's get through the queue.
Okay, just wanted to give a little bit of background on the draft that Jonathan mentioned. Richard and I worked on 5 or 6 years ago. Effectively is a combination of this and the previous presentation, but focused on opaque. what we did was we upgraded or added some additional records and things in the TLS layer to enable PAKEs to work there. And then we also defined a way that once they're in the TLS handshake and verified, you could cleanly abstract them with exported authenticators. And at the end of the day, this was meant to enable a draft at the HTTP layer where secondary auth could happen HTTP, and you would have the formal verification and analysis by kind of shipping David's org chart from TLS layer into TLS. And I saw that you referenced that draft in here. Just for the broader view, these sort of ideas have been explored a lot, and we didn't end up adopting it. We didn't have the best use case at the time.
Okay. Scott Fleur, Cisco Systems. Some people said that, gee, you could take this and just put it over to HTTP. That doesn't work because you need to somehow bind the later traffic to the PAKE, and there wouldn't be a way. I believe that with this design with TLS 1.3 does in fact do the necessary binding. That would need to be further analyzed.
Okay.
Thank you.
All right, so back again. We'd like to run a couple of calls for interest in the room. The first one being, do you think we should work on a mechanism for PAKEs in TLS? And that could be either of the approaches discussed today, but in general. So I'll start this. Hopefully I spelled it correctly. Yeah, okay. Looks good. Whoops, did I? Sorry. All right, the next one I think is, do you support PAKE in TLS handshake, which was the first approach? Put.
Is it just me, or I'm not seeing the second poll?
Well, I'm starting the poll right now. Sorry, I had to try to type it in, spell things correctly, etc. All right, looks like we're pretty stable. Did you get those numbers? And I'll.
Could you share the numbers or vocally? Because that way, when people watch the YouTube recording, the polls don't show up on the screen.
Okay. So for this one, there was 43 yes, 6 no, and 19 no opinion. Martin?
Yeah, I'm not sure that the questions are ones that I can answer right now. I saw the presentations, and I think generally, like technically, these are good, competent things to be doing. I'm not sure whether architecturally having the PAKE operate at the TLS layer is the right thing to do, and I just wanted to make that point.
Okay. I mean, obviously, this is not a binding consensus call. It's a call for interest, and we would have to take anything to the list. Stephen?
Yeah. So I think there's a long history of PEGs being kind of cryptographically acute things that turn out not to be useful. And I think we're going there again. I think asking the question the way you asked it is wrong. And I think it would be better to really ask who wants to actually use or implement this kind of thing. And I suspect the answers will be radically different. And I don't think the doing PEG in a TLS handshake is a good question at all.
Okay.
Steve, there have already been multiple vendors at the mic saying we want to ship this. So I don't know what you're looking for.
I'm not looking for any particular thing, but I do note that there is a history of PEGs being cryptographically acute for decades, never being used and never being useful. I don't think we should ignore that history of failed effort.
So Stephen, please scroll back through the chat. There's a bunch of links in there to actual deployments of PEGs in operation today, and a bunch of folks saying we plan to deploy these tomorrow if we define them. So like the evidence is there, just it's being used. The folks want to use it.
I remember similar statements from decades ago too. There are niches where PEGs may well be useful, but also I remember this whole entire thing being overblown many times and not being deployed. That's my recollection.
Chris Wood, yeah, that situation has definitely changed. PEGs are used everywhere at massive scales. Apple uses them basically for every single device. WhatsApp uses it for encrypted backups. There are other examples in the chat, and we have a very vested interest in shipping this. I'm kind of confused as to what the concern is, but hopefully that's like sufficient evidence.
Well, I assume you're asking me, Chris. I remember such declarations previously, and turns out these things did not get used. I'm not. Okay. I have nothing against them. They're cryptographically cute, nice things.
Wonderful. So we're going to go to our third question at this moment, which is: do you support doing PEG in TLS post handshake? You didn't get the... There are definitely some people have gotten it.
Can I ask a clarifying question? Can I ask a clarifying question? What does this mean? Like, if I do a PEG over TLS, that's not part of the TLS working group's decision, right? That's not what the question says. No.
Maybe it should have been a different preposition instead of in, perhaps. Yeah, and you, there are, I think Scott pointed out, there are connections to TLS in one way or another. Probably you would want to do in terms of key material binding, right? You don't have to do that, but you could, right? I don't know that this is going to change the outcome here terribly. Although it's pretty interesting to watch the bars. Okay. So I think we're going to stop here at 5 yes, 27 no's, and 33 or so no opinions, depending on when I click the button. So there's some instability in the, somebody's playing games out there. Thank you. All right. We're now into ECH, and I think, Nick, you are up first. Yes.
Just David Skenazy, based on those results, what are their chairs planning to do next?
Yeah, well, here.
I think it's pretty clear it's an adoption call for the first one.
Great. Can I ask when that will start? You could say soon.
Soon.
I don't know if we'll need 15. Maybe we will, maybe we won't. But so ECH, ECH has been deployed, but it's been blocked, right? The current ECH deployments stick out, which is one of the things that we wanted it to not do. The reason for which is that there are very few providers that are doing so. And so this is what happened in Russia. Very, very easy block. You look, is there an ECH extension? Is the outer SNI have the name of the only ECH config that's deployed on the internet? If yes to both, block, right? Very simple. So going into the ECH spec as currently written, there's some shoulds and mays here that really provide a pretty difficult interoperability hazard. For example, the outer SNI, which is the problem with this fingerprinting, is should be the public name. The public name is the name on the ECH config. And so violating that should is actually pretty difficult to do in practice if one were to try to. So part of the reason here is that on the server may choose to make sure that these are actually matching. And this can happen as like a secondary check ahead of time before even ECH is processed. So this basically makes this should like a huge hassle. And it's not just that, it's actually, if you go deeper into the spec here, you can see that if the server rejects ECH, you can have to send this ECH config back to the client. This is intended to help clients who have their ECH config out of sync or bad ones to be able to update it in band, right? But when the client receives that, it actually requires that it comes through a connection that is authenticated by that public name. So that public name, you need to be using TLS with a certificate that covers that public name. And then on the client side, if someone sends you an ECH retry update in a connection that is not authenticated by that name, then the client must reject. So this just makes it almost impossible to not use the public name, which is in the ECH config on DNS, as the outer SNI, making this whole thing very problematic. So if we were to allow this more broadly and try to facilitate the client being able to put different things other than the public name in this outer configuration, there's a difficult case that comes up, which is the server case where you don't have the keys, you've trial decrypted the ECH config and it fails, and then you can't tell whether the connection coming in is Greece or whether it's actually ECH with an expired config. Now, this is, I guess I did not update the slides. This is fine though.
Before we get into mechanism, would it be possible to discuss the motivation for this work?
The motivation is for ECH to not stick out.
No, I think I understand that, but I mean, Charles, I'm going to defer to you, but I think there's sort of like a disagreement at the core concept here that I'd like to try to surface. But I'll wait to the end if people prefer.
Okay, I think it's not sticking out. Currently, ECH sticks out. That's the point of this draft, right?
Okay, so I 100% agree ECH sticks out, but my point is that the providers have the service providers have an easy way of making ECH not stick out, which is use ECH all the time. And the reason they're not doing that is because they want to make they want to segregate the traffic which is blockable and traffic that's not blockable. And so my point is that why is a provider going to enable all traffic to be the ECH traffic to not be distinguished from ECH traffic?
I'm not a server operator, and I don't know that that's true actually. Maybe
I mean,
someone from the server
my
operator
point, my
space.
point is like you could just run a UCH galactically for every single customer in your network, and you have the same impact, which would be that either there's all ECH and you couldn't block the ECH, not block the non-ECH.
Maybe this would be best discussed at the end of the presentation.
Okay, but I mean, but the entire premise of the next two presentations is based on like this premise, right?
I mean, the premise is that in current deployments, it's extremely fingerprintable, which goes against the principle of ECH. That's just it. Do you disagree with that?
I think that's not. Yeah, actually, I do. But I'm happy.
It does not stick out.
I think it's absolutely fingerprintable. I just don't think that's the relevant. I don't think that's the right sort of game theory consideration.
Okay.
But again, I'm happy to step back.
When we go through this,
Sure.
I think it'll be more clear why this is just an exploration of the technical constraints here that were baked into ECH that imply interoperability issues and hazards. So in any case, the reason why this disambiguation that I mentioned right here, which is if it's ECH, then you have to according to the spec, return a ECH update config authenticated with the public name. That's what's been mandated here. Or it could actually be a grease connection coming in, and the server doesn't really know. But because in the current deployment scenarios where the public name is the outer SNI, both of these cases tend to have a recovery mechanism. So if it is grease, then the server will sign with the certificate that covers that outer name, and things will go along well. They'll send a retry config inside of it, and it'll be ignored by the client, right? If it's ECH, the retry ECH config, it's going to be signed by the public name, which is the outer SNI, and then it can just retry because it has a fresh ECH config that's been sent to it through the TLS connection. So the other option here is, if you want to have a different outer SNI and a different public name, and the server has a certificate that has both of these things on the one certificate, then you're actually in the same case. If it's grease, you ignore, keep going. If it's ECH, you get the new config and you retry. The issue here, and this is not a very common case, even at a lot of these large centralized providers, is that if the outer SNI is not the public name and there's no certificate that covers both, you actually get into a challenging issue right here. Because if the connection comes through and is grease, and the server uses the public name certificate, then the client has two different options, right? It can abort and retry with no grease because it knows that grease is failing in this connection due to certificate error. It's going to get a cert for the public name that doesn't cover the name that they asked for. So they can either choose to try ECH, sort of upgrade from grease to ECH in this config, or abort and try without grease. This is a really ugly case. The other case that pops up is the one in the corner here, where if it is ECH, but the ECH decryption fails, and the server assumes it's grease, then you're going to have a certificate that doesn't cover the public name, and so the ECH config will get rejected, and the client doesn't even know how to get an updated ECH config. So you ultimately, you would have to do a retry where the SNI on the outer part does match the public name, and then get a ECH config and then try again. It's a double retry case. So this is super problematic with the way this is all set up. So this is my draft that I published a few weeks ago. It's called Implicit ECH. Effectively, it just changes those shoulds and musts and mays in the document to signal new server behavior. So if the server wants to say, I promise not to enforce that the public name equals the outer SNI, which would enable clients to do various different strategies on their side in order to get through to the server and enable reachability, this it basically has these points. So there's you can put another flag. We have extensions in ECH config. So this would be a flag that says this server has the behavior of allowing the client to choose its strategy for these clients. And it basically just says must not abort, right? And if this flag is set in the ECH config, this is effectively deprecating the outer SNI for ECH connections. It would be used for reachability purposes only. Now, yeah, the client strategy for choosing outer SNI, not really defined here. This is basically a server config that is being defined by this draft. And so as of, if you just follow how the spec is currently written, everything else still applies. So any choice of valid DNS name can be used as per the ECH spec on the outside. So there's this disambiguation problem still exists, and it really is problematic here. And so I had some discussions with various folks about what the policy it could be, what ways we would have to resolve this. And one is, this doesn't really resolve it, but the server can advertise its disambiguation strategy. So whether it's going to go with outer SNI, which guess it's going to make for this disambiguation thing. But as you can see, there's no good case. If you choose the public name, you have both retry cases. And if you choose the outer SNI name, you're going to be good in the Greece case and have this double retry. And it's actually pretty difficult for a server to guarantee that the client that does support ECH is using ECH for a name without knowing what its view of the DNS is, or without knowing that it actually guarantees that it has the right config. So in any case, this needs to be solved somehow. The suggestion here is kind of simple. In ECH, the retry config is authenticated by the certificate on the connection that is sent back down when you send the retry. The name in the config matches the name in that certificate, and it's authenticated. This doesn't have to be done live. There's no strong reason for this to be a TLS live authentication of a name. This ECH config in stored in DNS could be signed. And that's sort of the proposal right here. And so if it's signed, then you can just use the server can choose the strategy of just always using the outer SNI. And in the case where it's ECH, if you send a signed config in a connection that's not signed by the public name, if the config itself is signed by the public name or something equivalent, then you don't have this double retry. You can just, you're going back to the normal safe case in ECH right now, where the name and the outer SNI has to match the ECH config. So effectively here, you're bringing the upgrade capabilities of the client in line with what you typically have in ECH right now, given a fixed outer name. Okay, so this is not in the draft yet. This is more thoughts on this. There's many potential options for having these signed configs. It's really nice to have these signed configs because you can actually sign them offline, sign them with an HSM, and you can keep this basically ECH config update key in much more secure than you would be able to keep the certificate that covers the public name. But in any case, there's a number of options here that can be laid out. You can have a sign it with actually a certificate, or something signed by the certificate with a delegated credential. You could set up a scheme with raw public keys where you have a list of hashes of future keys that are able to update this config, or you could even just put a DNSSEC signature chain as well. And this would really be something that needs to be sorted out. But in any case, this is implicit ECH. I'm happy to take questions, and hopefully that gives a little bit more context to Ecker with respect to what this really is, which is an exploration of the hard corners of shoulds and musts in the ECH draft as written.
Right. Alessandro.
So this seems to ignore the reason why the spec says that the servers may reject connections with the outer SNI that doesn't match public names, which was domain fronting. This has been discussed a bit on the list, but the fundamental problem is the servers, some servers at least, want to reject connections where the outer SNI doesn't match public name, and that's why the spec says that. It's not that the other way around where the servers reject because the spec says so. So
right. Yeah, so the spec here, it does not allow a server to assert that it will not do that check. That's the whole point here. Is if servers want to reject it, they want to use ECH as currently do, that's totally fine. This is enabling servers that don't want to make this kind of phony argument about domain fronting to be able to enable clients to actually interoperate with them.
So I'll just say that maybe a middle ground between the two options would be saying the client doesn't set outer SNI to anything, like it doesn't have
that sticks out immediately.
SNI.
That sticks out immediately. Having no outer SNI, there's no clients that do that right now. So it's going to be
right. That's what I'm saying.
Grease immediately. Like the whole point of this is to not stick out, to allow clients to put what they want in these names that they know will get through, and to know that the server treats it as deprecated. And yeah, I have a post I can make to the mailing list about why this is not domain fronting and why ECH and domain fronting are completely distinct. It basically comes down to whether or not the server is serving information that it's not authenticated to serve. That's what domain fronting is. In this case,
yeah, so
you're using the right certificate, so it's not domain fronting.
That's fine. So just want to say, I'm not saying we shouldn't work on this. It's just that we probably wouldn't be able to actually deploy this.
Can you explain why you would not? Maybe it's worth as a server provider to explain what technical reason you have for requiring the outer SNI to match.
It's not a technical reason. It's a sort of policy reason. In that the general policy is, you shouldn't be able to use our infrastructure to bypass security measures that, someone might have deployed at the client side. Say, one of those famous middle boxes blocks whatever SNI that is deployed on Cloudflare. You shouldn't be able to put, google.com on the outer SNI just to bypass check. That's fundamentally the domain fronting issue.
Okay,
gotcha.
We need to move on.
Let's move on to Steve. Thanks, Alessandro. Yeah, that's helpful.
Real quick, Stephen.
I'm always very quick. So I think we definitely should work on this problem. I don't think we have a good answer, but it's something we should work on. Nick's ideas are good. There are other ideas that are good, and we should just process it. But we should not hold up ECH on that basis. So let's work on this as a thing that we do after ECH has an ROC number.
Yeah, this is why it's an extension. It shouldn't block ECH.
I would also like to kill the idea of extensions there, but that's a different question. But yeah.
Thanks.
All right, let's make this quick. This is a little bit more color on the same problem. This is based on discussions that we've had with Nick and others. There's a few realizations about the shape of public names in ECH that I think are probably worth highlighting here. So in Eka's scenario before, ideally all public names are the same. You connect to any server and the public name is the same. Of course, modulo Alessandro's point about fronting, different operators probably want to use different public names. The outer SNI is probably going to be different on Cloudflare as it would be to connect to one of the Google services, for instance, to give the example you used. But of course, configuration management practices for a given operator are complicated, and you might want to have multiple different partitions within your own space. One of the realizations that I had working through all of this is that we've got this key ID, this 1 byte value that helps the server distinguish between different profiles of use. But you can also just use the public name as an extended part of that key. And you could imagine the Cloudflare ECH.com having Cloudflare ECH 1, 2, 3, 4, 5 pointing to completely different key configurations and different profiles on there. And as a practical matter, talking to folks about this, having a single name and a single profile across their entire operation is quite challenging in some ways operationally. So what if we took that to the next level and said, what if every connection you ever make uses a different public name? So imagine you have per connection public names. You effectively have some encryption of whatever information the server needs to do whatever it has. Here I'm using some sort of configuration ID. It could be some combination of configuration ID and information about the name of the server behind it. And you can just use a fresh connection encryption for every connection attempt that you make to the server. And then every connection is indistinguishable from every other one, even if they're using vastly different configurations. Does that not work? All right, there we are. So that's the ideal case. But if the public name to hidden name mapping is learned by someone else, they will get to know exactly what server you're connecting to. And you've kind of taken all the advantages of ECH and just unwound them completely. So the attacker learns hidden names in three different ways. They can decrypt. A little bit challenging, but you can make sure that the public-facing server is the only one that's able to decrypt the thing. That seems relatively straightforward. They can infer, which is a real problem, but let's not open Pandora's box right now. And maybe the more serious problem here is that when we provide people with ECH configurations, we do that via the DNS, which has this shared caching infrastructure shape, and it means that if you've gotten something from DNS, there's a good chance that some number of other people have gotten the same information from DNS as well. So the draft that I put together goes through some ideas of how to do this sort of thing. But one thing we realized is that retry configurations are always one-to-one-to-one. There's no situation where a retry configuration is available to anything other than the endpoint on the other end. So these are easy. If you get a retry configuration, that can include an encrypted public name, and it's almost ideal. It's not perfect in the sense that you need something to start with. You need to have the first public name that you, and of course, the first one becomes the problem, because if you're talking about connecting to a server and you don't want to reveal that you've connected to a particular server, that first attempt is the one that does the revealing. And it doesn't matter if subsequent connections are private, that first one has already broken the seal, as it were. So that gives us a bootstrapping problem. DNS records in caches. The people who are looking to see what servers you're connecting to are probably looking at the same caches as you are, particularly with public DNS. So this is where we get into the fun part of the presentation. I won't go into this in too much detail, but this is where we start sort of ideating, and Nick's proposal is kind of in this space, but we can have any number of interesting ideas that we put out there. And one of the reasons I wanted to talk about this was so that we can sort of start the cogs turning. And I know that I've had a couple of suggestions from other people since I put this out there. And so ideas are welcome. My first idea, just disable shared caching in the DNS. Not a problem at all, right? No one would see that as a problem for scalability or anything like that, right? So maybe not. You could do something to loosen the retry config. so that you could just go to random servers and get good configs in different ways. The one potential idea here is that you can just connect to an ordinary server using non-ECH, and it would be able to give you an ECH config somehow. You go to an HTTP well-known endpoint, and it's just sitting there. Or you can stick an extension in your new session ticket message or some new TLS message or something along those lines, and you get a retry config. That might work. The idea in the draft is, well, you could encrypt anyway and create some sort of interesting patterns of trying to avoid having adversaries see the same thing as you. There's some crazy stuff in here using EDNS 0 client subnet prefixes to separate out the things. Anything's possible in this space, and I just wanted to put some ideas out here to give people some sort of some basis for riffing on, so that we can try to come up with a better solution. And that's all I had. Thank you.
Go ahead.
Yeah, one thing I wanted to highlight, I think I brought it on the mailing list, is public name is used by some intermediaries as a routing construct. So there are three big use cases that I'm aware of. Some people do that for security reasons. They think that's a way to combat domain fronting. So they do look up and they see the destination IP and they replace destination IP with what they found. Some people do that for performance optimization reasons. That is, a client might have different view of what's the closest CDN node than cloud service that they're going through. And third one, the most horrific one, some people use destination NAT to send all the web traffic to some proxy, and then that proxy just uses either HTTP host header for clear text HTTP or SNI for anything that is TLS encrypted to figure out where to take that traffic. Now, yeah, I mean, all those use cases could be bad and evil from how internet is supposed to work, but they do exist. And if somebody would deploy ECH with public names that do not resolve to wherever it's supposed to go, then they would lose some random proportion of innocent users that has very little effect of how their little influence of how their traffic is taken. So this is something that I think we should keep in mind. And then finally, if we're talking about state censorship, then they also potentially could just do DNS lookup of all SNIs that go through their filters and see if it doesn't resolve or resolves to some strange places, then it should be blocked.
Yeah, so that's why the 7871 mention is here, because you can key based on the source IP address, so that people coming from different source IP addresses get different names that mean completely different things. The question about load balancing and whatnot, I think my general position on all of that is that if this is genuinely part of the server infrastructure and whatnot, make sure they have access to the keys. This is the attitude that we took with quick and connection IDs and the routing there. I think that applies equally here. If you're helpfully routing things from elsewhere in the network without access to this sort of information, I think we call that an attack, as opposed to like genuinely being part of a helpful infrastructure for the servers and their operations. So I think that's a pretty straightforward response to that concern.
Hey, Ben?
Hi, Ben Schwartz, Meta. I think that this basically runs into Ecker's same criteria as before. I think it basically is it doesn't work in the full game theory situation that we have to model to understand whether something helps here. in particular, if you have a name that means I'm using ECH here, and instead of that you have like a blob that's like encrypted blob, that also means I'm using ECH here. And the thing that you seem to be trying to hide is that I'm using ECH here, but it's revealed anyway. I think that some operational guidance, like, hey, please actually just use one name. Don't partition your anonymity set. Do your operational stuff in some other way. That might be worthwhile, but I don't think that this is going to help with that.
Nick?
Yeah, just a quick question clarification here. In this proposal for clients that do Greece, what is going to be in their outer SNI?
The clients doing Greece presently put the true name of the server as they understand it in the outer SNI.
Okay, so it seems that Ben's point stands, right?
Ben's point is basically correct, but that's not the angle that I was looking to take on this one. One of the advantages of something like this is it's potentially the case that a small operator can have names that are indistinguishable from another small operator or even a large operator, right? It doesn't your names don't necessarily reveal differences between different operators.
Right. So this is sort of differentiating configs, making them less identifiable on fire. Okay.
Right.
Real quick, Stephen.
Yeah, so I think we should work on this problem. I'm not sure that Martin or Nick's ideas are either entirely the right ones, but definitely we should work on it. And let's do that after ECH is a bit more deployed. And there is a reason for that. ECH being deployed currently kind of is about really large CDNs. Whenever it turns out to be the case that more than the really large CDNs might be deploying this, I think we might learn more. So let's work on this, but not just yet.
All right, Echo, real quick.
Yeah. Just to circle back to a point Ben made in the chat, I think there's sort of like a key question here, which is how much information does the attacker already have from the IP address? And I think if the assumption is that like you have very little information from the IP address, then a lot of this stuff seems to be like a lot more powerful. If the assumption is that from the IP address you can effectively identify the provider with very high fidelity, then these things seem to work a lot as well. So I think when we have this discussion later about what we're trying to accomplish, we really need to like try to drill on that some.
Okay, we're going to move on to the next presentation now.
Hi, folks. Sure.
To Ecker, we should keep the IP out of scope. We're not in an IP working group.
So,
did you give me control of the slides? Did Jill try this thing?
It says I'm. Oh, okay.
Yeah, we gave it to the clicker.
Okay, so I read Nick's thing and I read Martin's thing, and I decided that I wanted to do something that has fancier cryptography, which is obviously what we're all here for, right? So the anonymity set that Martin was talking about, it reveals the operator of the ECH. We want to make the different anonymity sets indistinguishable across all servers and across all operators. I'm pretending here that IP addresses don't exist. So it turns out there's a kind of encryption where you can do this operation. I have some encrypted blob. I can call this function re-randomize on it, and it will give me a different blob. And the only rule is it decrypts to the same thing. And the star is to indicate that I can call re-randomize as many times as I like, and it will always look completely indistinguishable from anything else. So imagine the authoritative DNS sets the name to the encryption of some secret key, to the public name and some, secret value. The server then sets its outer SNI on every new connection to the re-randomization of this encrypted blob. This has the very nice benefits that every connection uses a unique outer SNI. The outer SNI that you use never appears in any ECH config. You can't tell if two connections to, say, cloudflare.com are to cloudflare.com, or one is to cloudflare.com and one is to cdngs.com. And traffic in all anonymity sets, no matter which operator you're going to, has the same outer SNI format. And without extra metadata, all public names are completely indistinguishable. Okay, so I also have another way that uses less fancy cryptography and is much more boring, but perhaps easier. You can just do blinding. So the authoritative DNS sets the public name to some semi-static Diffie-Hellman key and the public name. The client sets their outer SNI to ephemeral Diffie-Hellman key, the hash of the shared secret, and the public name. Achieves the same goals, but I could probably prove this one in Tamron. You can shove the key share in there if you care about cut and paste attacks. I think I have another slide, but it doesn't want to. Yeah. So the problem with this is you're very easily distinguishable from Greece. Not sure this is definitely a problem. You could say, oh, actually, we're just going to ECH absolutely everything. And you can either block everything or not block everything. You can do re-randomization on the Greece public name, and then you're just reinventing ECH. But like, this solves what Alessandro brought up of let's say somebody wants to put google.com as their outer SNI and send that to Cloudflare, and we'll just be like, yeah, we don't pay attention to the outer SNI. We can terminate that anyway. So that solves this policy issue because you can check that it's valid. And for fallback termination, there's a really nice idea in Martin's draft that says, I put an SPKI in my DNS record, in my ECH config, and any certificate that has that SPKI is allowed to terminate. This is a little bit dangerous, I've just realized, because SPKI is allowed to be random bytes, but okay, whatever. Yeah, questions, thoughts, comments, hopes, dreams, whatever. Ben, hi.
Hi. So I feel like another thing that's potentially common among these three ideas, but applies here, is the whole point of the fallback flow is that it doesn't rely on a key. The fallback flow as specified doesn't rely on on any key being known between the client and the server, unless you except in the roots of trust. Like the only thing they have to agree on is the web PKI. And that is the only thing that's needed to bootstrap up. If you need the client and server to remember a key, then just don't forget your ECH config on the server side, right? Like the whole.
Well, so they don't need to remember a key, right? It's the SPKI. It's the hash of a key.
Okay, but there's no cryptographic material that needs to be remembered in order for the retry flow to work. If you have to remember cryptographic material or risk a total outage, then just remember your ECH private keys, and then you never have to use the fallback flow, and then we don't have to go into any complexity of trying to rescue the fallback flow.
Okay. Fair. Dennis?
Yeah, just to come in on that point, I think the key point about the fallback flow is that it doesn't rely on DNS. So it keeps things working even when DNS is messed up, or even when you've got a middle box. And it's important that we preserve those properties, but it doesn't necessarily need to hinge around like the web PKI for authentication. That's like a helpful thing. That's a helpful part of the solution, but I think not an essential one.
Martin?
Yeah, I was just going to say that Ben's completely wrong on that point. The fallback, you have to remember something. You have to remember the public name, and the public name is provided through the DNS. It's effectively provided by who we consider to be an attacker in this scenario. we don't rely on the fact that there is something like DNSSEC to authenticate these things. So the SPKI hash or whatever it is that we use is something you have to remember in order to recover. And that's something that is constant throughout all of these designs. I don't think there's any escaping the fact that you have to know something that's stable on the server side to recover from a failure of the key configs. And the reason that we have that is so that we can enable rotation of the keys on the server.
I mean, yeah, actually, if you think about this, you could just have in the DNS is the public name I will terminate with, and then you're just remembering a public name.
Right, yeah. So the problem with the current design is that the public name it has to be a DNS name, and it has to be a name for which the server operator is able to obtain a certificate for, and then we're hooking into the entire web PKI infrastructure in order to do that. And it has a number of advantages and a number of disadvantages, but that's just the nature of the solution. And realizing that this is just stuff that people put in the ECH config that could be something else is kind of liberating in this context.
Ben again.
Hi. I'm just going to say what I said again in a different way, and we'll see if we still disagree. Maybe we do. This design requires as I understand it, in order for fallback flow, requires the server to be able to decrypt the encrypted public name. If you can't decrypt the encrypted public name, then you can't execute the fallback flow. But in order to decrypt that, that means the server must be holding a private key that it remembers.
What? No. I think you've misunderstood the design then.
Okay, so it's not, is the public name encrypted?
Yes, but that's not what you're terminating with. Maybe I'm not clear. Okay, so you put in your public name random bytes. The server's like, hey, I don't recognize those random bytes. I'm just going to use an arbitrary, unrelated certificate that I just put the SPKI in DNS, right? Like I'm just going to use some cloudflare.com certificate and I've just put the hash, the public key in DNS. It's not related at all to the PN or this thing. Or this thing, which is
okay. Then I don't even know why you need the encryption, because then your fallback flow is just keyed by the SPKI effectively.
So this is in between Nick's idea and Martin's idea. So as Alessandro said, we can't do Nick's idea. Oh, it's hard for us to do Nick's idea because someone could put google.com in their what we're assuming is arbitrary bytes, because google.com is arbitrary bytes. And we don't want to terminate something which is a valid DNS name for somebody else, potentially. And so this is just like, we can check that this is something in our key space, but only because we have the private key.
Okay. Cool. That's weird. I would just leave it empty.
I've been told we can't leave it empty because of middle boxes and stuff.
Okay, maybe we can just IANA register a name that means like
this is ECH.
Go look at the SP. Yeah, this is ECH.
Did
Hey, the re-randomization option is PQ already. Yay, it's cheap. The blinding option is not. There can be blinding for a lot of PQ solutions. They're bigger and slower and not nice. So.
Interesting. I like the hashing option because it's like really easy to model.
Yeah, but the other one is like, oh, we don't have to worry about PQ. It's already there.
Sounds good.
Thanks. I'll just be quick. So I want to argue again with your argument that you can't do it, because if someone sends a connection to some Cloudflare site right now with google.com in the certificate, you'll finish that TLS handshake, right? This is something that's currently happening. We're not talking about enabling something new. And second, it's the client can choose different policies, right? If the issue here is that some middle box is resolving DNS in line and looking to see where it lands, the client can choose a policy of only using public names that they know resolve to the same AS, for example. And that doesn't create any issue with respect to violating security properties. And I tend to agree with Martin's description of what those DNS interception boxes are doing as an attack rather than as a security feature that so CDNs should be supporting.
So yeah, it's not a security policy. It's sorry, a security property. It's a policy property that we're trying to maintain. Yeah. Any other queues closed? Amazing.
All right, I think we have to move on. I think this is a good topic. I think, the existing ECH document will continue to go as it goes. And we have some stuff to work on for the next revision. All right, you'll get that. You should have, all right, Usama, you should have, yeah.
Perfect, thanks. So hello everybody, I am Usama from TU Dresden, and together with Mariam and Thomas, we have done some formal analysis of the internet draft that I will just describe. And I want to share some of the insights that we have from this formal analysis. And I'll take a moment to say thanks to my travel sponsor, GenXT, for me being here. The outline is to talk about some of the context, give you some idea of what this is about, and describe the problem and some of the problems that are still open. I have in the backup also the formal model that we have generated, and I already showed in the hack demo this Monday. So the context is there is this internet draft for Sati TLS attestation, and it was presented in the last IETF meeting. There was a mention of confidential computing as the main use case of the internet draft, and they asked for adoption of the draft. And we know there is a FAT requirement now, and the draft goes as deep as changing the key schedule itself. And I think it's pretty much clear it does need formal analysis. We don't even need to waste the time of the FAT committee for that. Formal analysis that we have done is, I'm going to present today some of that findings. And the main finding is that it breaks the main property, that is the server authentication property. And we propose some of the solutions, how this can be fixed, and some of the open problems that are still unsolved after all the discussions that we had throughout the week with a lot of the folks also in this room. Thanks a lot. And the challenge that we have is in all of this work is the terminology hell that's not coming from me myself, but also mentioned in the RATS working group a couple of days ago. And there are a number of rabbit holes which go down to the deep to the RATS working group, but I will not cover all of that. So it's a very abstracted view, just showing what the minimal that I need in order to show what the exact problem is, and to seek some of the reviews or to seek some of the ideas that might lead our way forward to the draft progressing forward. And from RATS perspective, what I do is the verifying relying party is my own term, which is kind of defining the verifier role as well as the relying party role from RFC 9334. And the core idea is that I believe, and not only believe, I mean that's clear. If we have the two parties merged together, that's going to be less security problems than having two separate parties, because you then also need to establish some secure channel between them. So my assumption here is that they have a perfectly secure channel, which definitely does not exist, there are indeed much more problems. So the idea overall of remote attestation I want to give in this slide. For those who are not familiar with remote attestation, on the left you see a figure which will be pretty much familiar in this room. That's the standard PKI infrastructure, which is that the certification authority as the trust anchor. On the right side, you see the remote attestation solution where the hardware manufacturer acts as the trust anchor. And the idea is that instead of having a CSR and a certificate, which is on the left, the hardware manufacturer typically injects an attestation key inside the attester, as is the terminology in RFC 9334. So that's the device which is under test. And the verifying relying party is the one which is verifying that device. So by some means, hardware manufacturer provides the verifying relying party with the public key with which it can verify that attestation evidence which it will be getting. And at the bottom is the comparison between what we call as the certificate. Comparatively in RFC 9334, there is an evidence. So there is a bit of analogy like for the CA key that's replaced by the attestation key, identity as we call it, for example, the host name and so on, that is replaced by the measurements, that is the hash of the piece of code running on the server. And the long-term key, all the formal proofs that have been done with the long-term key is in this case of remote attestation replaced by the ephemeral key. That is a self-signed key generated within the attester. Right, so there is a section 6.1 in the internet draft, which talks about remote attestation only solution. And we believe there is a lot of problem with that. And I'm going to explain that. The problem, so that says basically that we have a remote attestation only solution replacing the PKI instead of augmenting it. And the way it works is that we have, for example, a client wanting to go to cloud.example.com, and it's given a certificate which only contains the measurements of that and its public key. And an average cloud user would not be happy with this because that it has no PKI cert. It doesn't know what the identity of that particular data center is. And inside the measurements, there is no host name. The host name itself is never measured. That M does not contain any of that host name. That means it can be redirected to pretty much anywhere in the world. And that's not what we actually need. So our proposal is to basically augment rather than replacing server authentication, meaning to have a PKI cert as well as the remote attestation evidence, and to bind them together so that I'm sure that I'm connecting to this host, as well as I'm sure that this piece of code is running on the server. So that's pretty much the main thing that we need to have. Rather than replacing that, we should have both. And the challenge in order to do that is that the certificate verify message, of TLS 1.3 is not extensible. It can provide the proof of possession of only one key. Now we have two keys, one coming from the PKI, the other one coming from the attestation key. And for that, we have a few solutions which we want to discuss with the working group. Which one is let's say more suitable in this case, or which one is more acceptable to the working group rather than doing the formal verification of all. And we haven't verified any of those solutions. So it's just to get an idea if there is any opinion already in the working group. So on the left, you see the intra-handshake attestation. That's the internet draft that I already mentioned. And how this can solve the problem is, for instance, to use extension flag in order to modify the certificate verify message such that it does not provide a proof of possession of only one key. It may provide proof of possession of two keys. 1B option is to, rather than have only one certificate verify message, to allow multiple certificate verify messages. In the hackathon, there was also some mention of some other use cases which might also benefit from this other than remote attestation. So this might be more general than just for remote attestation specifically. And the second solution is to have a channel binder, but for that we need to change the key schedule in order to make it work. And on the right, we have a new internet draft, which I'm also an editor in. Hannes very kindly created a draft based on RFC 9261. The idea coming from Chris Patton. And basically what it says is that if server is the attester, the idea is that we do the PKI based completely standard TLS first with the PKI key, and then afterwards we add remote attestation part, which is that based on RFC 9261, we generate an authenticator request, in this case coming from the client, which is the client certificate request message. And the server will then provide the proof of possession of that specific key based on its certificate from the remote attestation, meaning that the first layer, the one-way authenticated channel, is for PKI, and the two messages below, the post-handshake authenticator, is for the remote attestation. Mike.
Hello, Mike Ellsworth. weird uses of certificates enthusiast. I'm mainly asking a question to the room here. So this is an interesting use case where there are two certificates, effectively a PKI cert and an IDEV ID cert, and we want to bring them both to a single handshake. Interesting, motivating use case. This is going to require bringing two certs to a single handshake. So sort of question for the room, is this a thing that we think is useful?
It's already done. It's already done. You spoke to authenticate. RFC 9261.
You need to talk into
It's already done. RFC 9261 is exactly that. My question is, why do you need a new draft? This is already totally, like, this is just the standard EA flow. What's new?
What's new in the post-handshake authentication solution?
Yeah, like it just looks like, and then we use EAs.
Do you want me to answer that?
So
yeah, whoever.
The stuff that comes from attestation is not necessarily an X549 certificate, and your draft says it only works for X549 certificates.
Oh God!
Thank you.
We were thinking about.
You could have made us the life so easy.
Yeah. I mean, I think there should just be like, let's rev EAs and get rid of the other stupid thing where only the server is allowed to request auth. But hey, that's just me.
Okay, so I will proceed. The open problems that none of these solutions, even if we pick, let's say, post-authentication or post-handshake, sorry, authentication or intra, it doesn't solve any of the following problems, namely, before going to the problem. So the original path is that how it is expected to work, assuming that any of the solutions that we pick up, we have the binding from both, assuming that a perfect solution exists in that case. So what happens is the TLS client is going to connect to the CSP, assume that this is some workload running on the cloud, and that's running in the virtual machine shown as a VM1 here. It has some measurements M1 and a private key priv EK1. And the thing is that now the quoting agent is the entity which will generate that evidence, the remote attestation evidence, which is shown here as M1 pub EK1, and it is signed by the priv EK1, the attestation key for that. And it will send over back that evidence to the VM. The VM will then send it over back to the client, and client has pub AK1, sorry, in its trust store, and based on that, it will accept that evidence because it has the measurements M1, which it expected. And the problem is that first, the CSP has, let's say, six digits machines in its cloud. So it can redirect it to any machine in there which it has compromised, and based on that, it can, so it could be done via many attacks such as foreshadow, as already been shown in the literature, for very small TCPs, even like for SGX. So the VM-based machines have even more like a bigger TCP and is more likely to be exploited and has been exploited. So I give this example only for a motivation case that smaller TCPs than the VM-based TEs have already been exploited. So the case is that it can redirect it to any machine that it has compromised. And based on that, it can do exactly the things that were mentioned before, that the client can never detect that it has been redirected to some other machine, because the CSP itself in the cloud confidential computing threat model is in control of everything. And then it cannot distinguish that because it has both keys in its trust store. The second problem is, Bob.
Bob Beck, private key enthusiast. You've got, you're trusting that pub AK1 and your pub AK2, sorry, in your trust store there. And you've handed private AK2, the corresponding private key, to a machine that is now, you're saying, compromised.
Mm-hmm.
So effectively that private key is compromised. Presumably it now signs a measurement that looks like the machine you want to be running, but it's a different machine without that measurement, and it is allowed to do that. At that point, you know, that this little turtle in part of this stack of turtles is no longer trusted, and this turtle should have something really bad done to it. Mm-hmm. You're not getting any security property from this whatsoever. And anything in that VM, including a web certificate that you put in that VM, because I could have run your other machine, pulled the private key for your web certificate out of that VM, put it in this VM, you can keep stacking as many compromised certificates as you want on this turtle, and this turtle is still not going to, this turtle is dead.
Yeah, so yes.
Yeah, I mean, this seems kind of tautological. If you trust something, for example, by putting it in your trust store, then you empower it to violate your security model if it's compromised. So if it's compromised, your security model is done for. So like, there's nothing you can do to solve that other than not trusting things.
Yeah, but the point is that we want to have, or the main goal of the editors was to have two roots of trust, or two trust anchors, and not single one. So breaking one breaks everything in this case.
So I might be able to sort of put a little bit of a different spin on this one that maybe not doesn't match up with the slides, but shows that there is a potential way to have this work that's not completely insane. The general threat model for a T or something like that is that physical access to the machine gives you essentially a blank check in terms of access to the contents of that VM. So you have to trust not just that it's running a particular piece of code within a particular T, but it's also running within an environment that you trust. And the idea that you might redirect from an environment that is trusted to one that is not is kind of a core part of this style of attack. And I generally agree that this attack is a real thing. And I would sort of say that the sorts of things you're contemplating are potential solutions to that sort of problem. But the way that I would structure that is that you've got a T that's running a particular piece of code, and it has an attestation that it's running that particular code bound to a private key that it's using. But in the case of the secondary authentication, that key can come from outside of that, from the trusted environment in which that T is operating. This is the
So the next slide is exactly that, right?
This is the example that I think is far more compelling than your option A, because in this case, the compromised server, which is running the same T, can produce the same attestation, but it doesn't have access to the private key that's running in the genuine infrastructure in there.
But
and that requires a particular structure of the code that's running in the T and a bunch of other things, but I think that's more compelling to me.
Right. So this proposal was also kind of discussed a lot for the last 2 months within the editors and us.
Yeah.
But the problem with this one is still that how does okay, so you can provide the certificate, but who owns the private key? How does it provide the proof of possession? So the entity which is shown here as encrypted workload, how does it get the key actually with the private key with which it will provide the proof of possession? So somehow it is dependent on the attestation being done, and attestation is dependent on this being provisioned.
Correct.
So there is now a chicken and egg problem, that which happens first, and how do we?
Well, most of these Ts operate. They don't operate in a vacuum with no communication with the outside world. They can be provided with things, and this private key could be provided as part of the bootstrapping process for the.
But there is a problem with that in the confidential computing threat model, you have the host as untrusted. So if it is provided by the host,
yes,
then you already don't trust that. So providing from the host is not possible.
We should probably take this on offline, given the time that we
Sure,
have,
sure.
but
Thanks a lot.
I think this is what.
Yeah. I like your idea, so I would love to discuss further. Thanks a lot. Who is next?
Victor.
Victor?
Hi. On Tuesday this week, Philip Allen Baker posted a message to the list. A different approach to attestation was the title. And I wonder whether you've had a look at that. It suggests being able to derive a single certificate, which at least for the case of EC, right, DH, is able to do something clever to get into a single certificate, both keys in an interesting way. Have you looked at that?
Right. So that basically, that email originated from our discussion with Philip. So that was basically an outcome of our discussion, but I don't think that solves the problem. Or rather, it shifts the problem to cryptographers. So none of us in our team, including the editors, is a cryptographer. So probably that needs to be taken up somewhere else. So at least we are not in a position to solve that.
Jonathan Hoyland, Cloudflare. So one of the properties of exported authenticators that I found in the security analysis I did is it has this property called compound auth. Go forward 2 slides, I think. One more, yeah. No, one more. There we go. So if you're using the exported authenticators case, you can be sure that if either key is uncompromised, then both were used honestly, which is a weird property. Like if you could have like priv AK has been published to Twitter and you can still be sure that it's being used honestly. So it's not clear to me, like if your threat model is only one of these keys leaks, then if you're using the EA design, you're fine anyway. And if your threat model is both keys are leaked, then you're toast either way. I don't.
So just to be clear, so just to clarify on this point, so I'm not saying that both keys are compromised. So we are saying that the attestation key is compromised, but there has to be, so on this slide, for instance, it can be provisioned from the outside, the second key.
Mm-hmm.
It never assumes at all. So the threat model that we are trying to tackle is that only one of the keys, namely the attestation key, is compromised, but not the long-term key. That is how that should complement actually.
So in theory, why doesn't EA give you this guarantee anyway? Because you have compound auth. So if either key is uncompromised, then both are used honestly.
So are you saying that using RFC 9261, if we have one of the keys compromised, it doesn't work? Is that right understanding?
No, if you have only one of the keys compromised, then you're secure. You have the same guarantee.
Okay.
Or at least if you don't have that same guarantee, then you're doing something wrong. You should have that same guarantee.
It's
Yeah.
okay. So
sorry, we are aware of it. I'm sorry.
Yeah.
If you got a quick comment, because we're over time.
Quick comment. Yeah. So the comment that I should have been on these slides, I would have loved if it had been on these slides, is that your attestation provides different properties than your PKI. Your attestation is like proof of stack, and your PKI includes cool things like revocation. And I think revocation is the thing that solves the turtle is dead, we should declare it an X turtle. And it's like this thing of let's bring 2 certs. In this case, it's cool because the 2 certs are doing different things. That's it. I sit down now.
Yeah. Thanks.
Thank you. All right. All right, we'll see you all on the list.
Okay.